I promise I don't want to take over the stage and always be the speaker. This is the second time I'm doing it. It's our second meetup. But I thought it was going to be easier to organize if I gave a talk. And I've been an Android developer for quite a while. I started in late 2010 and I continued from there. Before that, I was a web developer for a couple of years. And yeah, what I'm going to talk about today is reactive Android development with RxJava, and I put some terms that get thrown around when you're talking about reactive development. There's a lot of terminology. I don't want to confuse you with that too much. I'm going to probably have to mention it as I go. But I made a set of slides to introduce the topic. There's full of images, no text, so hopefully it's going to be easy for those who are not experienced developers and not too boring for those who are. Cool. So what we're going to be talking about is, you might have read that it said unidirectional data flow. So I wanted to talk about communication, right? And what is actually an application or a system. So this is an interaction with two people, something that probably happened today. You offer a beer, so you have a message that goes one way and then another one that returns. And it's a cycle. It could repeat forever. What happens when you replace one of these two humans with a computer? So you have a similar cycle, right? So the user can output commands or interact with the computer with peripherals or with their voice. There's different ways of communicating. And obviously that gets processed by the computer, and then the computer produces another output, which is the input for the human, right? All very easy. And then what you can interpret that is like as functions, because functions take some input and produce an output, right? So if you represent these parts of the communication as functions, you can think about this as the user intent model and view. So that was the acronym that you saw in the first slide, MVI. So it's basically saying, this is what the user intends to do. This is the model of the domain that we're working on. Could be the Uber app, could be TradeMe, could be any number of interactions that solve a specific problem. And depending on what the input is and certain conditions, you're going to get that represented in the view, and that's going to be the output. This is how the user receives feedback on the interaction they have. And then there's one more thing that could happen, which is you may have external things that are happening and sending message to your model, which are normally called side effects. So this is kind of like a quick overview of all the elements that the MVI kind of contemplates. And what I'm going to try and do is show you how, using these very simple concepts, you can actually create an application. And if you respect this model, you can actually make applications of different complexity. So yeah, that was just like an introduction, and then I'm going to do the dangerous bit, which is doing a demo. But I cheated. I'm not going to code it live. I'm just going to show you an exercise I did with different steps, and we can talk about it as we go. So let's try this presentation mode. It should be pretty good. Let's do project. So let's make sure I'm on the first step of it. So I made a very simple application, and I'm going to run it and see if I can show you what it is about. And we're going to work on that example. So it's probably this one. So I made a very simple application. So this is kind of the more advanced stage. But it's basically, there's a counter, there's a button. You can increment the value that's there, but it's also counting down. And you can interrupt the flow. So if you want, you can pause it, keep incrementing, and then resume, and it's going to start counting down again. So it's very simple. So I'm going to show you the basic code, a starting point for this. So basically, there's an activity. All it does, for those who don't know much about Android development, this inflates. The activities are like an entry point for your app. And what we're doing here is inflating a fragment, and a fragment represents a visual part of your app. So in this case, this is the whole screen, right? What we do here is just inflate a layout. And the layout, what it does is in XML, it will represent the text. In this case, just one of the buttons. The other button will get added afterwards. But it's basically just a simple representation of the view. So this is the button that increments the value, and this is the text view that will show you the current value, right? Okay, what else is in the fragment? And this gets a little bit more interesting. So you see that there's a view model there. And then we observe the state that's referenced by the view model. And what you see here is an expression that is updating the text view with the current time. That's pretty simple to understand. There's a view model, there's an object there that holds a state, and we can observe it, and we are updating. So there's this expression always makes sure that whatever the time is shown in the text view. And then this represents handling the output from the human in the graphic that we saw before. So this is the click. So this is how we capture the input or the output of the human and express. This is what would be our intent, right? This is what we want to do. We want to increment. Okay, I'm going to stop a little bit here. How many of you have heard of architecture components in Android? Okay, so it's not too many. So I'll try to briefly explain what's happening. A view model in Android, what it does in real practical terms is it survives for as long as the screen is alive. But because of how Android works, every time you change configurations, and the most common way of changing a configuration is rotating your device, the view has to be recreated completely so it fits the screen in the current orientation, for example. That's one example, that's the most common one. So the view model doesn't have to get destroyed. So all we do here, just so to let you know, the architecture components are kind of crucial for this implementation because they allow you to forget about the intricacies of Android. So you know that as long as your screen is alive in memory, that object will be there no matter what changes, and if it gets recreated. That view model will have a more intuitive life cycle than your actual view. So that's why it's there. That's why we need another object to do that. But let's continue. I'll show you what's in the view model. So this is basically all that happens in the app at the moment. So what you can see is that I have this thing here that represents the state. I have two because I don't want to expose the mutable states. I just want the view to access it. So basically that's all I'm doing here. Then I have the constructor, the initialization. What I do is just I initialize it with a random value, a custom value that I hard-coded in this case instead. And then this bit here, and you see here like there's an infinite loop that looks dangerous. This is like a very simple implementation I did with coroutines. All it does is, as long as the view model is alive, it will wait for a second and execute the decrement function. And then here are the two functions that do that basically increment and decrement what? The current count, which lives in the state. So what these are doing is increment obviously adds 1 to the current value, whatever it is, and decrement removes 1 only if the value is greater than 0. Otherwise, it will cap it on zeros and it will never go negative. So this is what the app does, and hopefully you've been able to follow up. So what I'm going to start showing you is how you can refactor this into something a little bit more interesting, and we're going to get to a more elaborate implementation of the same thing, really. Cool, so the first thing I will do, because this is kind of a lot of code that does a lot of different things in the same place, and that's not a good practice. We should have things that have a single responsibility. That's like the solid principles. So what I did here is I extracted a few of the things that are in the view model. So I started with modeling my domain logic closer to the graph that we said before. So I identified 2 things, states and events. And when I say events, I chose that terminology on purpose. It's what we would call an intent, really. The thing is that in Android, there's already something that we use that's called intent, that we use it to communicate different activities together. So it could be really confusing if you use the same terminology. But also, there's a lot of names that events have in different implementations. If anyone has done any React development, for example, you'll hear the term action. It's very similar. MBI, obviously, they talk about intent. I like event because event doesn't imply who triggered this. Action, to me, sounds a lot like somebody did it, right? And sometimes you want to represent something that happened with an event. It's kind of more generic. So in this case, there are two messages or 2 events, 2 intents that can exist in my domain or the problem I'm modeling now. So you can increment the count or decrement the count. Increment is done by the user when they click the button. We don't need to say that in the definition of the event. We don't care how it happens, but just so you can connect it back to what I showed. That's triggered by the user in this case. And then we have an automatic loop that's decrementing all the time. That's what triggers decrement. But we don't care. We just care that there's an event that happens that will request for something to happen. And then we have the state. And you see that the state has two parts of it. First, I added this time value to the state that represents the current time. But if you see here, this is a val, so it means that you cannot change it once you define it. If you want to change it, it should be variable. But we don't want that. We want it to be always know what is there, not letting anyone else change it. So that's the principle of immutability. You probably hear in React development and Flutter development as well. And the other part is the reduce function. And this is also a concept borrowed from React, and it's become very common. What this means is you have a function that takes in an event and also a state, and then produces a new state. How does that work? So if you think about it, our business logic, what is happening all the time is we get some input, which is the event. And depending on that input, our state is going to update. So the state is the representation of how everything is in our application. So in this case, our application has a very simple state. All we care about is what's the value of our counter now. And we're not talking about views or anything here. We're talking about the abstract concept of what our app does. So our app tracks time, and there's a certain value of the time at any given point, and that's represented by our state. The reduce function, as you see, gets an event. And this is very similar to a switch for those who don't know Kotlin. So it says, when the event is of type increment, copy myself, the state, but change my property time to be time plus 1. And then when the event is of type decrement, do the opposite. But in this case, we put some other arbitrary logic. We didn't have to do it, but we decided that we don't want the count to go below 0. So that's represented here. So this small change I made, I abstracted all the logic of my application, which is a super simple application at this point, outside of our view model. And you could argue that anyone can look at this without any of the other code. You could start with this, and you can define how your app works in an abstract way. We're not talking about the user interface. We're talking about what our app does, what's the main logic of it. I only had to do a few changes to the view model so far, so just replaced the minimum things I needed. So instead of having a live state that was just an integer that before, now I have an object which allows me to represent a more complex state if I need it in the future. And the other thing I've done, instead of making the modifications to the state right here, I just call the reduce function and send the input, which is the event. So I don't add or subtract, or none of that logic is here. It's all there now. Cool. Next step. And this is when we start using RxJava. How can RxJava help us improve the solution, or perhaps make it more robust? It may be an overkill for this. Probably we could have stopped in the first step, but I'm using it as an excuse to do a little bit more. So, and this will get a little bit more complicated, but basically all that ugly code that you saw at the top at the beginning, which I was doing just some crazy things to prevent the view to have access to to the state and modify it. I replaced that with these two things here. So how many of you have the chance to use reactive streams with the RxJS, RxJava, RxSwift? Okay, I'm worried that you're not the only one that's gonna get it here. But okay, so basically, I'll try to make it, to simplify the concept. But what I'm trying to use here are streams. So in programming, and this is something that's relatively new, and that's what made reactive streams famous, is the concept of using streams to connect stuff. So what's a stream? So you could say, if you have a variable that holds a value, and then you have an array that holds many values. A stream is, if you have one event and you have a stream, the stream is like an array over time. So it's events that keep coming. So that's why it's called a stream, right? So you have things that keep coming at you. And there are two types of streams. Streams that are hot and cold. I will not go into the detail, but what I'm using here is what's called a processor, which allows me to have hot streams. And hot streams basically is when you have events that you never know when they're going to come. A cold stream, you can predict when it's going to end, but in a hot stream, you don't know how long it's going to go for. So we want something like that, because you don't know how many interactions, how many times the user is going to press increment, and how fast. So you don't know how that's going to work. So you need something that's more like open and resilient. So basically what you have here is just two channels, so it's two lines, two timelines, in which you're going to be having events of different types, which are, the types are the ones I showed you before, increment and decrement. And then you're going to have states. So many state objects that may or may not contain the same or different values for the time. Okay, so once that's out of the way, what I'm doing here is exposing the state as live data. And live data, you could say, is also a stream. It's like an Android stream. It's a stream that solves a few of the implementation problems I mentioned before about when you rotate your screen and stuff. But it basically behaves very similar to this thing here. It will just give you the latest object it has, in this case, of type main state. Every time you observe it. You remember that we were observing the state. I'm going to refresh. Cool. If I show you again, this hasn't changed. There is a state. So the only thing that changes is I get a state object instead of an int. So all I'm doing is I know that that thing will give me a state every time it changes and I have to do something. And what I do, I define it here. And in this case, I'm just updating a text view. So basically, what I've done here is combined RxJava and live data just to transform the stream into something that works well with Android. But all we have is a stream of states. So I'm listening to it, and I know I'm going to get a state eventually, 1, 2, X, I don't know. I haven't changed this. And the other thing that you might notice, I have a disposable here that I dispose of and unclear. And I'm going to explain what's happening here. So I have a stream of events, and I'm saying, okay, scan that stream of events. So every time there's an event, just let it come and combine it with the latest state. So the event comes in, I check the state and say the state has a time of 7, and I got increment. So I'm going to say, okay, change it, give me a new state with 8, and I push it to the tube, and I wait for the next event. So this is what RxJava is doing in just one line, is expressing that concept. I'm listening to the events. Every time an event comes, I check what my latest state is, and then I make a new state with the modifications that apply. If it's increment, I have a new state that has 1 more than the previous one. If it's decrement, it will have 1 less, unless it's already 0. And that's how this expression will achieve that. And the thing is, this expression will be valid for any application. It won't change. That's what we always do, is we always get an event, and then this is the key. What will change is the implementation of reduce. What happens? What do I do with this event? How do I change this state? Or how do I produce a new state? So yeah, and with this very simple change, we already have we're using RxJava to manage the evolution of our app over time. Cool. Let's get to the next step. So in the next step, what I did is a very simple thing. In the beginning, we had a coroutine that had an infinite loop that didn't look great. And if we're using coroutines, some would argue, why do you use RxJava and coroutines? Why you may want to choose one. So what I did is, okay, I changed that so we can now have this timer, this 1 second thing that is sending a decrement event every 1 second, defined in RxJava. So basically, I can do that by creating another stream. So this is a stream that repeats every 1 second. And what I do is I subscribe to it. So every time that stream produces an empty value, in this case, I decrement. Decrement is I send an event down the pipes, and that goes back to a loop, and it's going to produce a new state. So everything kind of flows. We don't have to, every time we add something, we don't have to care too much about what happens. Here, this change is all about the state. The view we already implemented, we know how it works, we know how the state is. We didn't change the structure of the state. We just put something there, and this is what we called side effect in our graph before. So it's something there that's producing an event, and something's happening. So that's all I did. It's just to show you how you can also use RxJava for this kind of thing. And then I took this one step further. So I wanted to separate all that from my view model. So I wanted to make it very simple. So you will realize that now we have a new class called main model. We still have our live state, but now it's extracting the state from the model. So I moved the streams of events and state to the model, and I subscribe to the model. So if I click there, so I call this file my main model. So it's all the modeling of the domain logic of my app. And now I have the flow of events and state represented here. And here I declare the reduction of my state, but also a side effect. So I could start putting all side effects that I find that I need for my app. I can start declaring them here. So suddenly you will have a lot of stuff there, and there are ways to make sure that that doesn't grow into a super monster, and you can make separate functions for that, or there's ways to clean these up. But basically, you at least isolated all that logic into one place. And the reason you need to subscribe is because we want to obtain an object that we can say, okay, we're done now. So we don't want to listen to your timer, like kill everything. It's like the way out is disposing of all your subscriptions in RxJava. I think I'm gonna run this just to make sure, because it's all blah, 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 but I haven't been running it. So does it work? I don't know. This is the original state. It won't change though, you should notice any difference. But well, it will run eventually. I'm trying to move. Yeah, I don't want to bore you with lots of details. So in this other change, what I did is, okay, I wanted to add a new element, make it more complicated. How would that look like? Okay, I already have my stuff in place, but all I have is increment, decrement. Okay, what happens if I have a new requirement? How do I go about it? So, okay, I decided to add a button that, or add the ability to pause and resume the countdown, which is what I showed you at the beginning. So I had to think, okay, what I have is two events, pause and resume. So I need to add that to my mental model of my domain. So I added two objects in this case. I will clarify, you can use classes or data classes that have information that can change. Because here they are more like flags, like it's just the event that matters is what type of event and not the content. I'm using objects, but this could be anything. Basically, and something else I skipped, sealed class, what it does is it tells you these are the 4, in this case, events that are part of my domain. Anything else doesn't matter. This is all the events I could get. I won't get any other random object. Only events of time main event. And these are the 4. In this case, I added 2 more, increment, decrement, pause, and resume. And obviously, okay, I added that to the main, but then I need to know how they affect my state. So what did I do? So all I had in my state before was a timer. So how can I say if it's paused or not? I can't. I need something else. So what did I do? I added a value that tells me, it's a Boolean value, true or false, tells me if the timer is paused or not. And then this is all the logic, right? Okay, when I get an event of type pause, okay, copy the state, whichever it is, and notice that I'm not declaring time like here. I'm saying copy the event, which means copy everything, and you can only override what you want to change. So I'm going to get the exact copy of the previous state, but I'm making sure that the value is true this time because I paused it. And if it's resume, I'm going to make it false. You could do it differently. You could say instead of pause and resume, you could have one single event that's called toggle, and then change whatever was there. If it was true, you say false. If it's false, you say true. there are pros and cons to the approach, but you can model things however you like. Here I thought, well, because if I press pause too quickly, or there are other things that press pause, this is more safe. Because I meant pause, I didn't mean resume. If you say toggle, okay, it depends on what was there. It's going to change. It's very hard to predict what's going to happen. Okay, so I did my domain modeling now. Okay, but what happens in the view? Okay, what do I do with that? So I need to change the view as well to reflect this new state, because we don't have to, but we want to do something with it, so we're going to do it. So if you go to the fragment, what you're going to see is that besides this part that was there before, we update the text view to show the current time. We now have a reference to a toggle button that I'm going to show you in a second. I added the toggle value obviously here. So now we have, I called it toggle because there's only one button, but it will have it can only have either one state or the other. It's paused or it's resumed. So that's my button there. And I do two things. When the state tells me that it's paused, I make sure that it reads resume, because now the button, what it does is resume the countdown. And I make sure that when you click on it,
no, that's just English.
Is it? Has it gone bananas?
Yeah, cool. All right, so what I'm making sure is that when you click the event, now it resumes. If the state was not paused, which is the else here, it means it's resumed. So I say, okay, read pause, because when the user presses, I want it to pause. And I make sure that that is the intent that we send, so I pause it. So again, yeah, that should change the button soon. Takes a while to compile. That's all it changed. And I have one more thing to show you, which is, okay, we are letting the view know about what the state has done, right? How the state has changed. But what happens when I want to show a message of success, let's say? So in this case, what I want to do is say, okay, when you post successfully, I want to show you like a quick prompt that says, you have paused the countdown. And the same for when you resumed. Okay, what I could do is I could read the state, right? And say, okay, it's paused now. Yeah, but is that actually what I want to do? Because if I do that, every time I subscribe to the state, I'm going to have to show a message. But I want to only show it when it happens the first time, right? So this is something that you may come across, and we have come across this on training. It's a problem that you need to solve sometimes. So we're still arguing about it, but I argue that the view should be able to know about what events are available. So what I did in this step is do something similar to what I was doing with the state for the events. So I exposed the events, and I added an observer of the stream of events instead of the stream of state, which is listening for what events are coming in. So in this case, every time the user presses one of those buttons, I'm going to tell them, okay, you're pausing the countdown, or you are resuming the countdown. That's something else you can do. And the only difference that you notice here is that I'm not just keeping a reference to the original live data reactive stream. I am using this syntax from Kotlin. What this is going to do is every time the fragment asks for a reference to this stream, it's going to give it a new one. This is a bit of a hack. It's the simplest hack I could come up with, but the problem is the way live data works, it will always give you, every time you subscribe, the latest event. So what happens if you press the button, you receive the event, and you say, you show the message, right? But now you rotate the device. The fragment is going to die and be recreated, and it's going to subscribe again, and it's going to receive the latest event, and it's going to show you the message again. So you can go, and you get 100 events, and the truth is that you haven't pressed the button again, so you shouldn't be getting that. So by resetting the stream of live data every time is an easy way to make sure that you start from scratch, so when the viewer subscribes again, it won't get the message again. So yeah, this is just to show you that it works. So what I forgot to show you is what the pause and resume events do to the state. And the other thing that we needed to, I added, and this is a way I decided to implement it. It doesn't have to be done this way, but I had to update the logic, right? So what I'm saying is, if the countdown is paused, in this case, it doesn't matter that I'm receiving a decrement, just return the same state, because I'm not changing. So that's what pause does, is kind of skips processing the decrement event in this case. Now, if it's not paused, keep doing what you were doing before. Subtract 1 unless we're in 0 already. So this is a way to implement this. It's not the best. Why? Because if you wanted to allow the user to decrement, but the user doesn't have to do with being paused or not, because if you want to trigger that event manually, you should be able to decrement even if I had to add a decrement button there. So, but yeah, I mean, those are details, and I think I left it there because that's probably a good exercise for you guys to do if you want to. I'm going to share the code of this. What if you had another requirement? Okay, I want also to have a decrement button. Okay, this won't work, so find a way to do it. And there are different ways to do it. You could do it just by doing something in the side effects part to post things, or but yeah, you need to find the right way. But that's the thing. It's like your requirements are going to evolve, and you have to decide how you're going to implement your logic. So yeah, to wrap up, this is kind of, I just wanted to share a train of thought, and I did it in different commits, so anyone can grab that code and try and go back and go step by step and see how the thought process goes. But by implementing this kind of solution, which is a unidirectional data flow, you have intents that go this way, and then the input and the output kind of go in circles. And what you're not doing is what you would do originally, like an MVC architecture, which is this some class that knows everything in the middle, and it is updating the state and also updates the view and knows and sends message in every direction. You are reacting to what happens. That's why it's reactive. And RxJava, the reason why I like the solution so far is because it's a very good implementation of streams, but it's not the only implementation, and there's a lot of emerging technologies that allow you to do that. If you ever try Flutter, which is one of Google's new technologies to do mobile development, they have a Dart implementation of streams, which you could use to do something very similar to this. Kotlin has done a lot of progress with coroutines, and the equivalent to streams, apparently, and I haven't really had a chance, I don't think it's finished yet even, but there's a concept called channels in Kotlin that allow you to represent streams of data that's coming through. You could probably implement a similar solution. You don't have to use RxJava. The advantage of RxJava or Rx in general is that you have implementations for different languages. So you can use RxSwift, RxJS, and RxDart even. So there's lots of other solutions. So you could transport this implementation to different platforms and languages pretty easily. Yeah. Cool. Is there any questions or anything that you would like to me to explain more or go back to. I burned your brains.
You know the thing you were doing to get round the rotation?
Yes.
And resetting the stuff?
Yes.
If you'd put on the on the stream itself, you'd put I don't know, distinct until changed or something.
Right.
Would that have also fixed the same thing, or? Is
Yeah, I'm not sure because you will have to do it at live data level. I don't know if live data has anything that would prevent it from producing a result when you subscribe. The last time I checked, and it was not long ago, that was impossible. And there is a library called Single Live Event that tries to solve that by adding like wrapping the events in another object that's like a consumable object. So once it's been consumed, it will be produced, but you would ignore it. And so that's another solution that many go for. And yeah, that I think that is a problem. The live data is very limited in scope, and they are not trying to make it more complex. That you don't have a lot of operators that you can run on it. So yeah, that's why this is a hack. There's many other solutions. In TradeMe, for example, we have our own personal solution to make sure that when you have a live data, you have consumables as well. We made our own consumables. So basically, you get an event and you can either, I think in the beginning, I don't know if we changed that, we had a variable. So you can actually override a flag of the event the first time you read it. And then it's going to be ignored every time afterwards. Yeah. Cool. Any other questions?
Well, all of these things cause pressure on CPU or memory consumption.
That's a good point. I think it depends on what you're modeling. If you see, like here, we were producing a new state every second, basically, because we had a counter. So if you have something that updates very quickly, because our state is immutable, you are allocating memory like crazy, right? You're creating a new object every time. It's a very light object. In this case, had like a few variables, so it may not be an issue. If you have a regular user app that will only change every time the user attaches something, that's quite slow and quite acceptable. And the thing is, the domain logic tends to be, or the model tends to be quite light. So you are creating very small objects. It's still memory allocation. It could be a concern depending how complex your app is or how intensive it is. So you may not want to use this approach for a video game. I don't know. Or, I really haven't measured what the limit is.
It's fixed for me. It's fixed some problems because there's like throttle keywords and stuff like that. So you can basically throttle the how frequently you're getting events through, and it will basically window those up and then give you the latest. So it will drop, last half seconds worth and then give you the latest one, which then actually reduces the amount of load on the rest of the system if you've got loads of stuff screaming at you.
Right. Yeah, but that you can actually adopt some techniques just to avoid that. Like if you don't want to process a lot of events too quickly because it doesn't make sense, you can do
Like
that.
if you've got bits of your app that aren't interested in all the state, or super timely state. So it doesn't matter, say a network spinner isn't spinning quite at the right time. If it's half a second off, then you can just only ignore state updates, and you only get them once every half a second rather than the whole time. So
if you are interested in this topic, this is all stolen from Facebook's React library. There's a Redux framework that kind of started this conversation of having a single state that represents everything. So just to avoid mistakes and errors, and having a well-defined logic for the domain, knowing exactly what events could happen and how they act. And so because it's very easy to understand when things break or what's not working. So you could go that way. If you try Flutter as well. Flutter, there's quite a few patterns that go in the same direction. They use Redux for Flutter, or you can use something called the block pattern that's quite similar. But yeah, this is something that I think is going to be present in front-end development everywhere. So it's definitely something that's interesting to learn. This is one approach. There will be many, but the concepts, the underlying concepts will be similar. Cool. All right. Well, yeah. Thanks. Cool.